Hi students, today class we are going to talk about solution, suspension and colloid. Okay, okay. It's all about the particles. Okay, so the size of the particles has a great effect on the properties of a mixture. So you must observe a mixture's properties before deciding whether it is heterogeneous or homogeneous. Okay, mixtures get classified as solutions, suspensions or colloids based on particle size. Now, what is the solutions? The question I am asking, when sugar is dissolved in water, it forms what kind of mixture, students? The answer is homogeneous mixture. Okay, homo means same. When substance dissolve and form a homogeneous mixture, the mixture is called a solution. Okay, when substance dissolve and form a homogeneous mixture, the mixture is called a solution. Whatever substance there is more of is called the solvent. Okay, whatever substance there is more is called as a solvent. The other is called the solute. For example, water is a solvent. Okay, sugar is a solute. Okay, so it will be mixed, we call as solution. Okay, when substance dissolve and form a homogeneous mixture, the mixture is called a solution. Okay, the another example, the iced tea, the solvent is the water, the solute is the tea mix. Okay, and now what is meant by properties of a solution? They do not separate into layers over time. Okay, if they are poured through a filter, none of the substance will get trapped. Okay, and then light passes through them. Okay, the three important thing is they do not separate into layers over time. Okay, because it is a homogeneous. If they are poured through a filter, none of the substance will get trapped, and then light passes through them. Okay, light passes through them. All of the particles in a solution are too small to become separated and filter out or scattered light. All of the particles in a solution are too small to become separated, filter out or scatter light. And then for suspension, you are seeing flour in water, like other liquids that need to be shaken well before using. Okay, shaken well before using are called as suspension. And then another example will be the muddy water taken from a swamp is another example. Okay, so we have already learned that a solution is homogeneous mixture composed of two or more substances. For example, salt solution and sugar solution. Okay, what are the solutions? What are the salt solution and sugar solution? Suspension and colloids are heterogeneous mixture. Okay, suspension and colloids are heterogeneous mixture. And then see the difference in solutions, suspension and colloids is due to difference in their particle size. Okay, so in solution the size of the particles is smallest than suspension and colloids. Okay, in solution the size of the particle is smallest than suspension and colloids, and then colloids have particle size in between that of a solution and suspension. Now students, colloids have particle size in between that of a solution and suspension. Okay, look at that example, students. The flashlight passes through that solution, colloid, suspension. For solution it will be transparent, colloid translucent. Okay, and suspension translucent or opaque. Now, what is meant by suspension? A suspension is a heterogeneous mixture in which solid particles are dispersed in a medium and remain suspended. Okay, it is opaque or translucent and its particles are visible. Some solids like chalk, sand, etc., and some liquids like oil, petrol cannot dissolve in water and hence form a suspension. Okay, and then what is meant by colloid, students? colloid. The definition is a colloid is a heterogeneous mixture. Okay, heterogeneous mixture means two or more in which solid particles neither dissolve nor settle down at the bottom. Okay, a colloid is a heterogeneous mixture in which solid particles neither dissolve nor settle down at the bottom. It is translucent and the particles can be seen by microscope. Students, it is translucent and the particles can be seen by microscope. For example, milk, blood, ink, etc. are some examples of colloids. Okay. Another topic is water of crystallization. Okay. You see the crystal? Anybody see the crystals? Water of crystallization or water of hydration are the water molecules that get attached to some solid substances and give them crystalline shape. Okay, what is the water of crystallization? Also we call as water of hydration. Okay, these are the water molecules that get attached to some solid substances and give them crystalline shape. Okay, and then it is the fixed number of water molecules that are loosely bound with one molecule of a substance. Okay, see student, it's a fixed number of water molecules. It may be 5. Okay, here they are giving 5 water of crystallization. Okay, so the salts which contains water of crystallization are called, that is, hydrated salts. The water of crystallization in hydrated salt, it represented by dot in their chemical formula. So only we are seeing here CuSO4 into 5H2O dot. Okay, so this dot in their chemical formula is represented by dot. For example, copper sulfate crystal has 5 water of crystallization. Okay, for example, copper sulfate crystal has 5 water of crystallization and its formula is CuSO4 into 5H2O. It is blue in color. Okay, it is blue in color. See students, this is the example of water of crystallization. First one is copper sulfate and another one is a white crystal. Okay. Now another topic is anhydrous substances. What is meant by anhydrous substances? Substances which do not contain water of crystallization are called anhydrous substances. Which do not contain water of crystallization. Okay. So the hydrated salts on heating, it converted into anhydrous substances. Okay, hydrated salts on heating. So the here is a heating. Heating will be, we are giving that hydrated salt. So once we heat, it will be converted into anhydrous substances. For example, copper sulfate pentahydrate. That one lastly we talk about copper sulfate into dot, that chemical formula 5H2O. Same the example for this also. CuSO4 into 5H2O. On heating, loses its 5 water of crystallization and gets converted into anhydrous copper sulfate CuSO4. And it is to be noted that all crystals do not possesses water of crystallization. For example, NaCl sodium chloride, PbCl2 lead chloride, KNO3 potassium nitrate, NH4Cl ammonia chloride, etc. These are anhydrous substances as these do not possesses water of crystallization. Okay. For example, see if you are seeing that silica gel in any new material, if you are buying, means the inside this silica gel will be available because it is anhydrous compounds contain no water. Okay, it will be what, dry silica gel. Okay, it will be absorb the moisture. Okay, it will be absorb the moisture. This is the example for anhydrous substances. Okay, and then efflorescence. What is meant by efflorescence? Some substances with the water of crystallization have property of losing their water of crystallization wholly or partly when the crystals are exposed to dry air even for a short time. Okay, students, some substances with the water of crystallization have property of losing their water of crystallization wholly or partly when the crystals are exposed to dry air even for a short time. Such substances are called efflorescent, and this phenomenon is called a efflorescence. So efflorescent substances are transformed into powdery mass after release of water molecules. For example, washing soda, sodium carbonate. Okay, washing soda we call as Na2CO3, that is sodium carbonate. And then Glaber salt. Glaber salt means Na2SO4, sodium sulfate into 10H2O, and copper sulfate are efflorescence substances. Okay, the another topic is deliquescence. What is deliquescence? Some substances some substances absorb moisture from air and become moist. Okay, if you are seeing our salt, okay, it absorb moisture from air and become moist, okay, in opening time. So the deliquescence means some substances absorb moisture from air and become moist. They lose their crystalline form and ultimately dissolve in the absorbed water and change into solution. Okay, they lose their crystalline form and ultimately dissolve in the absorbed water and change into solution. Such substances are called deliquescent substances, and this phenomenon is called a deliquescence. For example, ferric chloride, FeCl3, caustic soda, NaOH, calcium chloride, CaCl2 are the example of deliquescent substances.